Okay, I think we can start now. Can you please confirm the screen is visible or not?
Yeah, doctor.
It is visible, no? Okay, okay. Okay, so in this week, actually, we have started with the discrete Fourier transform DFT. So, yesterday in the lecture, we have seen how to apply DFT, how to apply inverse DFT to get the sequence in the discrete time, from discrete time domain to the frequency, discrete frequency domain. If we want the particular signal or sequence in that particular domain, then we can apply DFT, and again we can also get back the uh, original signal using inverse DFT. Now, like in the time domain where we are having constraint over the frequency, sampling frequency, like it should be at least twice the natural frequency of the signal. So like this, in this DFT, the constraint is actually over the size of the sequence, so that we should choose appropriately, so that n should be at least uh, equal to the length of the signal in time domain, so that we need to choose. And we have seen a couple of examples yesterday, so we will continue with that. And we have also gone through the properties of this system, DFT. Okay, so we have seen the periodicity, linearity. Basically, it is linear, it is periodic in nature. Then we have seen the basically DFT is based on the circular effect. Circular effect, or you can say it is the periodic effect. You can also say this is having the periodic effect because this is periodic signal you will get. Okay, like in case of DTFT. So in case of DTFT, there was the signal you will get, it may be a periodic signal. Okay, so but in case of DFT, you will get always a periodic signal. Okay, now, so we have seen how will be the response in frequency domain. Well, there is a time shift in the time domain. If there is a frequency shift in the time domain, what will be the, or how will be the frequency domain response? That these properties are very important: time shift, circular time shift, and circular frequency shift. Okay, and there is one more property is very important, that is circular convolution. Okay, now linear convolution, basically we represent with the star notation, like x of n is linearly convolved with y of n. This is linear convolution. In case of circular convolution, we represent with circle, inside circle there is symbol n. So that is n point DFT. Okay, or you can say the modular n. So here always we write n here, subscript to the subscript. So this n is nothing but the modulo n. We say this is modular n. Okay, so in circular convolution, how we write? X of n is circularly convolved with y of n. So this is the representation for circular convolution. Okay, now circular convolution, how we write the circular convolution? So first we'll see how I will represent. Suppose y of n is equal to g of n convolved with h of n, and this is linear convolution. Suppose I say linear convolution. For linear, I am writing here subscript L. Okay, this is linear convolution. Now, if I want to expand this, so I will write this like summation of g of m into h of n minus m, and this summation is basically over from 0 to capital N minus 1. Okay, and this will goes from 0, 1 till 2m minus 2. This and will goes from this. Okay, now in case of circular convolution, for circular convolution I am writing yc, c as a subscript, yc of n. So this is basically g of n is, this is the symbol for circular convolution with h of n. Okay, now here if I want to expand this, so I will write this is g of m, h of n minus m. This m will goes from 0 to n minus 1, but this is over modulo n. So the sequence will repeat after every n interval. Okay. Now, this we will understand with one example. So let us take the example for this. Okay. Now let us take two sequences. Suppose there is sequence g of n. This is 4. The size of this sequence, this is 4 point, or we can say this sequence is having size 4 and equal to 4. That is 1, 2, 0, 1. No need to write commas also. H of n, let us say h of n is 2, 2, 1, 1. Okay, and this is started with n equal to 0 here. Arrow represent the starting of the sequence at n equal to 0 here. Now suppose I want to find out circular convolution for this. So I will write y circular convolution of this is nothing but g of n circularly convolved with h of n, and if this is basically equal to, this is basically equal to summation of m from 0 to n minus 1 g of m h of n minus m. Okay, now to calculate this circular convolution we will make some table. Now just a second. Sorry for the interruption. Okay, now with the help of the table we will calculate this. I'm audible to you. So first we will write m. So m will basically goes from 0 to n minus 1. So n is having value 4. So this is m will vary from 0, 1, 2 and 3. Okay. Now we'll write the sequence g of m. So I say g of m is what is given here 1, 2, 0, 1. Then h of m is basically 2, 2, 1, 1. This is the given data. Correct. Now, if I want to find out the yc of 0, so what is yc of 0 here? Yc of 0, so you need to put n equal to 0 here. Okay, so that is equal to summation over m equal to 0 to n minus 1 into g of m into h of minus m. Correct? If I put n equal to 0 here, and for the first value of yc, this is summation over g of m into h of minus m. So first thing is we need to find out h of minus m here. Okay, so h of minus m is what? This h of minus m over modulo 4. We are having value n is n equal to 4. Therefore, I have written here 4. Okay. Now, this h of minus m is nothing but what? For 0 value, it will be 0. H of minus 1 is what? H of minus 1, I will say this is equal to h of n minus 1 because this is circular in nature. Therefore, h of 3, 4 minus 1, 3. Therefore, the value of h of 3, this is the value of h of 3. This is h of 0, h of 1, h of 2, h of 3. So this h of 3 will come here. Okay. H of 3 is nothing but h of minus 1. Okay. So this will come here. So I will write here 1. Okay. What about h of minus 2? This is equal to h of 2. Therefore, this is same. And what about h of minus 3? H of minus 3 is nothing but h of 1. So this will come here. Okay. So I will write 2 here. Okay. So h of minus m is basically, I will say this is equal to h of 4 minus m. Okay, so like that I have calculated this. Okay, now this is easy to calculate yc of 0. So for yc of 0, now I can put the value here. Yc of 0 is nothing but so yc of 0 is nothing but summation over this, multiplication of this. So this is what? G of 0 into h of 0 plus g of 1 into h of minus 1 plus g of 2 into h of minus 2 plus g of 3 into h of minus 3. Okay. So summation of this. So I have expanded this term like this. Okay. Now g of 0 is this. H of 0 is this. G of 1 is this, h of minus 1 is this. So we need to multiply this thing. Calculate the yc of 0, we will multiply this thing. Okay, so this is again 2 plus 2 into 1 2 plus 0 into 1 is 0 plus this is 2. So the value you will get is 6 here. Okay, so like this we can calculate yc of 0. Now similarly we will calculate y1 of 0, yc of 1. So yc of 1 is what? This is summation of m of 0 equal to n minus 1 g of m, and this is h of 1 minus m. Okay, so now we will calculate h of 1 minus m. So 1 minus m is what? So if I put here 0, so zeroth value is nothing but, if I put m equal to 0 here, so, or you can say that this is basically shifted by the, your this sequence will shift it by 1 towards the right. So this will shift like this 2 you will get here, 1 you will get here, 1 you will get here, and this 2 will goes here and this will come across this. Okay, so you will get the sequence like this. Okay, this term is basically comes here. Now suppose I want to find h of 2 minus m. So in that case again this shifted version will towards shift by 1 towards right. So you will get the sequence like this. Okay, h of 3 minus m. I can find like this. Again, this will shift by 1. Therefore, this is 2. This 2 will come here and this 1 will come here. Okay, so with this shortcut, you can write like this. This table you can write like this. Now, this is basically confusing. So I will remove these arrows. Okay, now you can easily find out the y1 yc of 1. So yc of 1 is what? Summation over this ym into h of 1 minus m. So gm into h of 1 minus m. So this is constant. This is having, we are not doing anything to this. So this g of m into h of 1 minus m, if you multiply this and if you do the summation, so you will get the value of yc of 1. So I will write here yc of 1 is nothing but 1 into 2, that is 2, plus 2 into 2, this is 4, plus 0 into 1 is 0, and 1 into 1 is 1. So 0 plus 1, this is equal to 7. Okay. So like that, yc of 2 is equal to yc of 3 equal to. Can you tell me what is the value of yc of 2 from this table? So yc of 2, I will say the multiplication of g of m into h of 2 minus m. Okay, so you multiply these values, 1 into 1 plus 2 into 2, 0 into 2, and 1 into 1. Okay, so what you will get here? How much you are getting? Are you following or not? So this is
Yeah,
1,
doctor. Wait.
1 plus 4 plus 0 plus 1. So this you will get 6. Similarly, you can find YC of 3. So that is equal to the multiplication of this. So 1 into 1 is 1 plus 2 plus this is 0 plus 2. So this is 5. Okay. So the final answer is YC of n is summation of all this YC of 0, YC of 1, YC of 2, and YC of 3. Okay. So this is equal to what we have got is 6, 7, 6, 5. Okay. So like this, we can find out the circular convolution for these two sequences. Okay. There is one more method, like in the last lecture also we have seen the other method, that is method 2, I say. So we can multiply this given sequences in the frequency domain and we can do the IDFT of that. So this IDFT of, if I multiply G of k and H of k, then also I can get the this circular convolution of this YC of n. Okay. So what I need to do here, I'm having G of n, I'm having H of n. So from G of n, I will calculate capital G of k. From this, I will calculate capital H of k. Then, so this G of k is what? This is summation n equal to 0 to 3 G of n e to the power minus j2 pi by n k into n. Yesterday we have seen this formula. Okay, so like this we can calculate here n equal to 4 for our given sequence. So like this we will calculate g of h, g of k and h of k. Then what we will do, we will multiply this g of k into h of k. Whatever you will get, you will get the answer for this. Then the you need to apply the inverse DFT to get back the signal. So that is the formula 1 by n summation from k equal to 0. I will say k here, from 0 to n minus 3, n minus 1, that is 3, g of k, h of k, and this is to the power e to the power plus j 2 pi n k into n, like this. Okay, so you please try this example using this method too. Okay, now can you calculate g of k and tell me the answer? Please calculate g of k. Calculate g of k first. So g of n is given. What was g of n? G of n is 1201. For this given g of n, calculate g of k. Please give me the answer for g of k. What is the first value in g of k? Can you tell me? Yes. Yes, what is the value of g of k? First value.
Is it 5, doctor? 4.
4 is correct. Yes, 4. Others, are you getting 4? Then the second value. Yes, what will be the second value?
Still calculating, doctor.
Okay. Yes, what you are getting? Still calculating? Others, are you solving or not? Yes, any difficulty in calculating this? Mm-mm.
Is it 2 minus j?
Check it once. It should be 1 minus j.
1.
Are you getting 1 minus j there?
Yeah, doctor. I already
You're
found where
getting, no?
I made.
Okay. What is the third value? So if you solve this, you will get 1 minus j there. Okay. Yes, tell me the third value and fourth value.
Is the third value equals to negative j?
Third value? Third value
Yeah,
should be equal to minus 2.
minus a.
Minus 2. Okay, now to calculate this, you need to know these values. What is cos of pi by 2? What is sine of pi by 2? What is cos of 3 pi by 2? What is sine of 3 pi by 2? Okay, so what is cos of pi by 2?
0, doctor.
This is 0. This is equal to 0. What is sine of pi by 2? This is equal to 1. What about cos of 3 pi by 2?
0
And sine of 3 pi by 2?
equals to negative 1.
That is minus 1. Okay, so this is equal to 1 into 0 is 0. Oh, sorry, this is not 0, no. This is e to the power 0 is 1. 1 plus 2 into 1 plus 0 plus 1 into minus 1. Hmm. This is 0. This is 1 into 0. I made it wrong. Just a second. J is multiplied, no? This is 1 plus 2 into minus j times 1, that is minus j, plus 0, I will skip 1 into minus minus plus j here. Minus j into minus 1 is plus j. Okay. So 1 minus 2j plus j. So what you will get here? 1 minus j. So 1 minus j should be the answer for this. Now for the third, are you getting minus 2 here?
I'm still working on it, Doctor.
Similarly, find g of 2. G of 2 means we are calculating g at k equal to 2. This is summation from n equal to 0 to 3 g of n e to the power minus j. I'm directly writing here pi by 2. K is what? 2 into n. Okay. Again, this 2 will get cancelled. So this is basically equal to summation from n equal to 0 to 3 g of n e to the power minus j pi into n. Okay. So if you expand this, this is g of 0 into e to the power minus j pi into 0 plus g of 1 e to the power minus j pi plus g of 2 e to the power minus j 2 pi plus g of 3 e to the power minus j 3 pi. Okay, this is equal to what? G of 0 value is what? G of 0 from the given sequence, it is 1. Okay, 1 2 0 1 now. So this is 1 into 1 plus 2 into e to the power j pi means what? Cos of pi minus j sine of pi plus this is third value is 0. This is equal to 0. So this whole term will be 0. Okay, so I'm writing 0 directly here. G of 3 again it is 1. So 1 into cos of 3 pi minus j sine of 3 pi. Okay. Now, what is cos pi? Cos pi is how much? Cos pi is
Negative
minus
1.
1. Right. What is sine pi?
0.
Sine pi is 0. Cos of 3 pi?
Minus 1.
This is again minus 1. Sine of 3 pi?
0.
This is 0. Okay, now put the value and get the answer. This is 1 into 1 is 1 plus 2 into minus 1 plus 1 into minus 1. Correct? So this is what? 1 minus 2 minus 1. So 1 minus 1 will cancel. So you will get minus 2 here. So you should get minus 2. Okay. Similarly, you calculate for last value. What will be the last value? You just check it. It should be 1 plus j. Okay. Similarly, find out h of k. Now h of k, I'm just writing the answer. You can check it. You should get 6, 1 minus j, 0, 1 plus j. Okay. And if you multiply, you now multiply g of k, h of k. Okay, you will get answer and then do the inverse multiplication to get back signal yc of n. Okay, so this is 1 by n summation n equal to 0 to n minus 1. So instead of n, I will write k here. So g of k, h of k, e to the power plus j 2 pi by n, k into n, like this. Okay. So you should get the answer y of n is equal to whatever we have solved in the previous example, that is 6765. Okay, 6765. You should get this answer after doing this. Okay, so do this at home. Okay, so we will stop here today for this tutorial. So this is very important example. Okay, so please do practice. Okay, cross check your answer with this. I have already given the answer. H of k answer is this, and when you calculate this g of k, h of k, it is simple. Only need to multiply this, and then if you do the inverse of this, you should get this answer. Okay. Yes, any
Oh,
doubt in this?
no, doctor.
Okay, you understood the procedure. Okay, this is the second method for this. The first method we have seen with this table. So this is basically easy to calculate instead of this. Okay, the table you will find easy, but there is other method like this. So sometimes you may ask to follow this other method. So in that case, you need to do all this calculation. Okay, so we will stop here today. Okay, any doubt in this?
I don't think so, doctor.
Okay, okay, then we'll stop it. Thank you. Thank you. Have a good day.
Okay, doctor.